Electricity. It's invisible, yet it powers our modern world. From the moment our alarm clocks buzz us awake to the soft glow of our bedside lamps at night, electricity is an integral part of our lives. We rely on it for lighting, cooking, entertainment, communication, and countless other aspects of our daily routines. It's easy to take this powerful force for granted, but understanding its potential dangers is crucial for our safety and well-being. While electricity offers undeniable convenience, it's essential to remember that it can also pose serious hazards if not handled with care. Electrical accidents can result in severe injuries, fires, and even fatalities. By understanding the basics of electricity and adopting safe practices, we can significantly reduce the risks associated with this powerful energy source. This guide aims to empower you with the knowledge and tools to navigate the world of electricity safely. We'll delve into the fundamental concepts of electricity, explore common electrical hazards, and outline practical safety measures to protect yourself and your loved ones. Remember, electrical safety is not about living in fear. It's about understanding the risks and taking proactive steps to mitigate them. By embracing safety-conscious habits, we can harness the power of electricity while minimizing the potential for accidents. This proactive approach ensures that we enjoy the benefits of this essential energy source without compromising our well-being. Let's embark on this journey of electrical safety together and create a safer environment for ourselves and our communities. Before we dive into the specifics of electrical hazards, let's familiarize ourselves with the fundamental language of electricity, voltage, and current. Imagine electricity flowing like water through a pipe. Voltage, measured in volts, is akin to the water pressure pushing the flow. Current, measured in amperes or amps, represents the amount of water flowing through the pipe per unit of time. Voltage is the force that drives electrical energy through a circuit. It represents the electrical potential difference between 2 points. A higher voltage indicates a greater potential for electrical energy to flow. Just like higher water pressure results in a stronger flow, higher voltage can lead to a more powerful electrical current. Current, on the other hand, is the rate at which electrical charge flows through a conductor. It's the actual flow of electrons through a circuit. A higher current means more electrons are passing through a point per second. Think of it as a wider pipe, allowing more water to flow through. Understanding the relationship between voltage and current is crucial for grasping electrical safety. High voltage alone might not pose an immediate danger if there's no path for the current to flow. However, when a path is present, such as when we touch a live wire, high voltage can drive a large current through our body, leading to severe electric shocks. Electrical hazards manifest in various forms, but electric shocks and burns are among the most common and dangerous. Understanding how these hazards occur is the first step towards effective prevention. Let's explore these hazards in detail. An electric shock occurs when our body becomes a path for electrical current to flow. This can happen if we touch an exposed live wire, use faulty electrical appliances, or come into contact with water that's in contact with an electrical source. The severity of an electric shock depends on the amount of current flowing through the body, the duration of contact, and the path the current takes. Electrical burns are another serious hazard, often resulting from high currents passing through the body or from the heat generated by an electrical arc. An electrical arc occurs when electricity jumps between two conductors or from a conductor to the ground, creating an intense burst of heat. These burns can range from superficial skin burns to deep tissue damage, often requiring immediate medical attention. The human body is a relatively good conductor of electricity, making us vulnerable to electric shocks. When current flows through our body, it disrupts the normal electrical signals that control our muscles and organs. This disruption can cause muscle contractions, irregular heartbeat, difficulty breathing, and even death in severe cases. Preventing electric shocks and burns requires a multifaceted approach, including awareness of potential hazards, safe work practices, and the use of protective equipment. By understanding the risks and adopting safety measures, we can significantly reduce the likelihood of these electrical accidents. Our homes are wired to handle a specific electrical load. When we exceed this load by plugging in too many devices or using appliances that draw excessive power, we risk overloading the circuit. This overload can lead to overheating wires, melted insulation, and even electrical fires. Thankfully, fuses and circuit breakers act as safety devices to prevent these dangerous situations. Fuses and circuit breakers are designed to interrupt the flow of electricity in the event of an overload or short circuit. A fuse contains a thin metal wire that melts when excessive current passes through it, breaking the circuit and stopping the flow of electricity. Once a fuse blows, it needs to be replaced with a new one of the same amperage rating. Circuit breakers, on the other hand, are reusable safety devices. When a circuit breaker detects an overload or short circuit, it trips, interrupting the flow of electricity. Unlike fuses, circuit breakers don't need to be replaced. They can be reset by flipping a switch once the fault in the circuit is identified and rectified. Modern homes typically use circuit breakers instead of fuses due to their convenience and reusability. Both fuses and circuit breakers play a crucial role in preventing electrical overloads, protecting our homes and appliances from damage, and ensuring our safety. It's important to understand the amperage rating of our circuits and avoid overloading them. Using power strips with built-in surge protectors can provide an additional layer of protection for our electronic devices. Regular inspection of our electrical system by a qualified electrician can help identify and address potential issues before they escalate into hazardous situations. Grounding and polarization are two essential safety features designed to protect us from electric shocks. These concepts might sound technical, but understanding their basic principles can significantly enhance our safety awareness. Let's break them down. Grounding provides a safe path for stray electrical current to flow directly into the earth, preventing it from passing through our bodies. Electrical appliances with metal casings are typically equipped with a three-prong plug. The third prong, the round one, connects the appliance to a grounding wire, ensuring that any fault current is safely diverted to the ground. Polarization, on the other hand, ensures that electricity flows in a predetermined direction within a circuit. Electrical outlets with polarized slots, one wider than the other, are designed to accommodate polarized plugs. These plugs have one wide blade and one narrow blade, ensuring that the appliance is connected to the circuit in a specific way. This polarization helps prevent electric shocks by ensuring that the appliance's metal parts are connected to the neutral wire, which has a lower electrical potential. If a fault occurs and a live wire comes into contact with the metal casing, the grounding system will divert the current to the ground, preventing a potentially dangerous shock. Regularly inspecting our electrical cords and plugs for damage is crucial. Frayed cords, cracked insulation, or bent prongs can compromise the grounding and polarization safety features, increasing the risk of electric shocks. If you notice any damage, it's essential to replace the cord or appliance immediately. Thank you for watching. If you found this video helpful, please give it a thumbs up and subscribe to my YouTube channel for more content on electrical safety and other important topics. Stay safe and see you in the next video.